Okay, hi, welcome. This is the first of four videos, which I hope will guide you through some kind of general information about hypothesis testing. And I'm starting with the tools that we can use for statistical analysis, because a lot of what you do next will be guided by what tools you're doing in terms of how you prepare your data and so on. Now, there are lots of different options available in terms of what tools you want to use. You can, towards the left of this, you've got R, you've got MATLAB, and so these are kind of typically more kind of programmer type tools, if I can call them that. So they rely on you having some kind of programmatic or at least logical knowledge that you can use commands to create the test that you want to use. SPSS I've put there as probably the kind of middle ground. So that's a stats package for social sciences, and that uses some kind of menu-driven interactions and has some kind of Excel type familiar environments to it. And then the last one there at the right, at the opposite end of the spectrum, is Excel, which is obviously very familiar, hopefully, to you in terms of it's a Microsoft environment. We've all seen an Excel sheet. We all know roughly how they work. We know how the menus work and so on. There are also a number of tools available online. So if you just Google, t-test calculator, t-test analysis, you'll get lots of online tools that you can use. These tools are valuable if you know that you need to do one, but you need to be really sure that you can trust that tool. As you should see as we progress through this, even though I say t-test, there are lots of different versions of what a t-test is, and so you need to be really sure that you're using the right one. Sometimes it's not clear what particular type of t-test a tool is going to use. For the purposes of this, moving forward, we're going to use Excel as our example to work through, because that's something I hope that you all have access to. So this is what R or MATLAB looks like. So this is a screen grab from R, and it's actually with a GUI on top. So what you find is that on the left-hand side, there's the R console. You type things into that, you call up files. So anyone who's used to kind of using any kind of like DOS type environment will be comfortable. Anyone who isn't, that's an extra level of needing to learn the commands, and it's a bit more difficult to explore than having an interface. So if you don't have a GUI, you need to know what those commands are. If you don't know what they are, it's harder to find them, and so it's kind of time consuming. But it's very powerful if you're doing a lot of complex statistical things, so lots of things to do with science, life sciences, engineering, that all happens in R or MATLAB. Just a bit more complicated than what we currently need at the moment, but it's a great kind of tool if you find yourself needing any kind of statistics in the future. I would say spending the effort to learn MATLAB is going to be worth it. You'll get some reward if you do. So this middle ground, your statistical package for social sciences. This one is kind of quite menu driven. It's got spreadsheet data. The output can be complex, so you often see a lot of people kind of complaining about the complexity of the output of SPSS. But again, it's a very powerful tool. You can store a lot of data in there. You can do a lot of data manipulation that if you didn't have a specific statistical package to do would take a lot of mathematics behind it. So if you are looking for something that uses statistics, but you're kind of a little bit intimidated perhaps by the R MATLAB type environment, SPSS is a really good middle ground for that. And then you've got Excel, which is obviously a familiar environment. If you're doing something more complex, it can be a bit slower in terms of both its processing and in terms of you setting it up to do that, because sometimes there needs to be some kind of fiddling around. But if you look on your Excel, you should see a data tab, and that data tab should give you a data analysis option. If you don't, you can go to that link there, and so this will be typically if you've got a Mac, because for some versions of Excel on Mac, data analysis tools don't come, they're an add-on. So there's some information on that file there about how to go and download that data analysis add-on. So let's say we've decided we're going to use Excel. We need to have a look at what are the components of our code or our data, and how are we going to prepare that to be used in the stats environment that we've chosen. So first thing is that the data we get from participants needs cleaning, and by that I mean that data is not perfect. That data is going to be missing things. So if you have a survey, for example, or you've got a test and a participant somehow only does 9 trials and you wanted them to do 10, what do you do with that data? If a participant inputs their age into the demographics form and the age says 223, you can assume that they made an error there. So did they just mean 23? Or did they actually mean 22 and their finger slipped? So how much tolerance do you have for those kind of errors? And things like making sure that all your kind of descriptors are the same. This commonly happens when you have different experimenters perhaps putting data in. So making sure that everybody uses the same kind of library of terms. And if you have an open field for age, what you need to write in is that if someone writes 12, you'd probably need to convert that to the numerical 12 so that you can then do your analysis. Sometimes you get some really interesting responses, like you'll be 10 in August. So you've got, okay, well, he's 9 now. So I can put a 9 in there. So this, of all of the analysis process, this section of preparing takes the longest. You then need to, depending on what software you're using, sometimes they don't accept textual-based things. So I could have, if we think of the example we've been working on for finger input versus nose input, if I label them finger and nose, it might not work because it wants a numerical thing. Primarily because it's faster. If you've got a lot of data, it's faster to parse a 0 or a 1 than it is to parse finger input, nose input many times, right? So sometimes you have to just code all those categories using numerical values. And then you need to make sure that it matches the expected input for your stats software. So the example for this is SPSS. If you have information for 2 categories, your time, your error rate, whatever it is, if those are the same participant did both things, it's going to maybe want you to rearrange it in a slightly different way than if each participant only did one thing. So being aware of what your stats package wants from you can also take a little bit of time. Obviously, there's tutorials and stuff that you can work from, but you are going to find that that whole preparation thing takes time. That preparation is subject to human error, so it's a time to be kind of really careful on what it is you're doing. So from that, you have everything prepared and you're ready to then start looking at the analysis. So that should give you a bit of a summary of the tools that you could possibly use for statistical analysis. And for the purposes of what we're going to do for the rest of this week, we are going to use Excel.